All right, guys, so here is Unit 6.3, Part 2, using cosines to find the area of an oblique triangle. Now, again, before we start this one, some of you might recall that we used sines earlier in section 6.1. So a formula like this, 1/2 AB cosine of C. This was handy when we had an oblique triangle that we had side, angle, side given. But if we're given a situation where we're given side, 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 given 3 side lengths of a triangle, this formula using cosines called Huron's formula will come in handy. Now, some of you in geometry might have learned Huron's formula, if you recognize this at all. This S stands for semi-perimeter. I don't know if that rings a bell to anybody, but you need these two formulas to help you find the area of an oblique triangle using cosines. Now, I actually looked into the proof of this. It does use Pythagorean theorem in similar triangles, but that proof itself would take the full 15 minutes of this video. So again, unfortunately, I decided for the sake of time not to show it to you, but I know for a fact that there are proofs online, or if anyone's interested in class, I'm sure I would be happy to show it to you. I'm sure Ms. Schwartz or Mr. Lakin would be happy to if needed. So, to find the area of the triangle, I think we should just jump on into it so that we know how these are applied. So if you're given 3 sides of a triangle, let me draw any oblique triangle. Again, I'll call it ABC for the sake of it. It looks like the longest side is 3.05, so I'll call this angle A because this is my longest side. So 3.05. B is the smallest side, so I'll call this B because this is across, so 0.75, and then this would be C at 2.45. Okay, so now that I have a visual, first thing I need to find is this semi-perimeter, because you might notice in Huron's formula, you take the semi-perimeter and then multiply the semi-perimeter with the difference of every side that already exists. A, B, and C stand for the sides that already exist. So if I found the semi-perimeter, that is defined as the sum of all the sides, 3.05 plus 2.45 plus 0.75, all divided by 2. If I calculated that, I got my semi-perimeter to be 3.125. Feel free to check me on that in your own calculator. So if I have side, 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 it only works if I have the 3 sides initially. The area would be the semi-perimeter, which is 3.125, and multiply that times the subtraction of the semi-perimeter minus each side. So semi-perimeter minus A, semi-perimeter minus B, and semi-perimeter minus C. Now I'm writing out all my work. Some of you might prefer to do this more in your calculator initially. I'm just showing you this on the notes. So this would really be 3.125. This first parenthesis reduces to be 2.375. The second one ends up being 0.675. And the next one ends up being 0.075. So if I keep following the order of operations and multiplying what's underneath my grouping symbol first, multiplying all of these together, I think would get me, just for the sake of the work, let me check that, 3.125 times 2.375 times 0.675 times 0.075. That would get me 0.375732 dot dot dot. But then I still need to take the square root. So second square root, second answer. I got my area to be very small, 0.613 units squared. So the area of this triangle, using Huron's formula, will be 0.613 units squared. Now the interesting part, could I go back way in time and drop an altitude and maybe use trig or maybe use some other form? Sure, but that would take you a lot longer. Could I maybe use this formula up here from the Law of Sines? Probably, but you'd probably have to use the Law of Cosines first to find an angle and then use it, which again would be longer. So I would say again, if you happen to have a triangle with side, 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 Huron's is your best bet. Last problem. A parking lot has the shape of a parallelogram. And if you guys remember, a parallelogram is defined as having opposite sides congruent, opposite sides parallel as well, and so forth. The lengths of two adjacent, so that means sides that are next to each other, are 70 and 100. So this side could be 70 and this side could be 100 units or meters. The angle between the two sides is 70 degrees. What is the area of the parking lot? Okay, so first, if I were to do this area problem using the law of cosines, because this video really has to do with the law of cosines, what I'd have to do is first draw a triangle. Then the law of cosines needs an angle directly across from a side. So first thing I'd have to do is, and just kind of bear with me on this, first thing I'd have to do is find x. So I'd have to say x squared equals 70 squared plus 100 squared minus 2 times 70 times 100 cosine of 70. So I'd have to find x first to find the area of just one of these triangles. Because eventually, if I want to use the law of cosines, the law of cosine helps me find x. Then once I find x, that helps me use Heron's formula, which is that square root of s minus a, s minus b, s minus c. So if I have all three sides, I could use Heron's after I find this. And then once I find Heron's, remember, the red is only half the area. So then if I multiplied that area times 2, then I'd have the area of my parallelogram, because that's split into two triangles. If anyone else is exhausted from listening to me talk about that, I'm just as exhausted. I do agree that that method would work, that the law of cosines would lead to Heron's because of side, and go so and so on. But if I were you, I would think back to geometry. I teach geometry as well, and I love it. So let's see. Is anyone thinking to themselves, man, I think I learned a formula for the area of a parallelogram? You did. The area of any parallelogram is just base times height. But just like with the triangles, the height has to be perpendicular, or it has to form a right angle. So let me draw a similar picture here. Let me draw a parallelogram that has two adjacent sides, 70 and 100, where the angle in the middle is also 70 degrees. Now, if I want to draw a perpendicular height, I could draw it on the outside, but I could also draw a perpendicular height from the top corner down here. So I have, let me try to make this a little bit more neat here. So I would have a triangle here where I have a 90-degree angle, and it was given to me, this little angle here is 70. If I want to find area as base times height, the base of my parallelogram is the 70 in this case, the way that I happen to draw it, because the base is defined as the segment that is perpendicular to the height. Is the 70 perpendicular to the height that I drew? Yes, it is. And so what I need to do is find that height. I wonder if I can. Well, if I look at the right triangle here, I have an angle and I have opposite and hypotenuse. So I think we've actually seen this a couple times before. Let's use right triangle trig. Sine of 70 degrees equals opposite the height over the hypotenuse 100. So the height is really 100 times the sine of 70. So that means that the area, base times height of my parallelogram, is base 70 times height 100 times the sine of 70 degrees. And if I type that into my calculator, I would get that the area is 6,577.848 meters squared. And I don't know about you, but if I actually went through all those steps with this one over here, I got the exact same answer. But the reason I picked this example for the notes is to tell you, if you remember things from geometry about parallelograms, trapezoids, any shape, and you want to use it, feel free, because I think that knowledge is powerful. best of luck to you studying for final exams, and you'll hear from me again second semester. Thanks.